Every day, around 350,000 babies are born, each one utterly unique. A few months ago, this baby didn't even exist, and the story of how it came to be, against impossible odds, is extraordinary. This is the moment of conception, when one single sperm fused with the mother's egg. If another sperm had got there first, this baby would be someone else. So what made that winning sperm so special? Why did it succeed over billions of others? To find out, we're going to take you on the epic journey sperm undertake through the human body. And we're going to do it by scaling the whole thing up to human size. For the first time, we'll be able to appreciate just what an extraordinary journey sperm face as they try to reach the egg. It's one of nature's most spectacular stories, and it's the reason you're alive. The sperm will face death at every turn. There is no going back, no surrender, and only one winner. Meet Glenn. Like most average men, Glenn has no idea about the miracle of engineering, tucked away in his pants. Glenn's testicles, hanging freely to be 3 degrees cooler than the rest of his body, are producing 1,000 sperm with every heartbeat. And it's this tiny world of frenetic activity that fascinates the world of reproductive science.
Sperm are really quite unique because they're almost like free-living cells. They almost have a life of their own. They have but one aim, which is to deliver a genetic payload from the male to the female through a really quite complex series of environments, both in the male and the female reproductive tracts.
Sperm move all over the place, and they like certain things, they don't like certain things. They're very smart little creatures in a way, and they're a lot of fun to watch in the Petri dish because they're constantly in motion.
And the fact that it's occurring at the microscopic level means that as scientists we have a great deal of difficulty in studying it and observing it.
A sperm is just 1/500th of a millimetre long. So to make things easier, Dr. Alan Pacey and a team of experts have agreed to help us scale up them and their world 34,000 times. The first thing we asked our experts was quite simple. In our people-sized sperm world, what would a testicle be like?
The testicle is a roundish, kind of oblong structure. If we cut it in half, we cut thin layers through it and looked at it down a microscope, we would see a series of tubules that you might liken to floors of a building. If we were to take a sperm and scale it up to man size, you would have to find a building that was about 1,000 metres cubed, 1,000 metres by 1,000 metres by 1,000 metres.
That done, we can go inside. Waiting in our giant testicle, an army of freshly created sperm. Just like the real thing, our sperm are split by gender. Half produce boys and half produce girls. The information needed to determine the sex of a baby is stored in a sperm's head. Here, we find their genetic package, 23 chromosomes of DNA, including the key gender chromosome, either X for a girl or Y for a boy. Situated just below the head, an engine of energy-producing mitochondria that propels the sperm's mighty tail through the female body.
Many millions of sperm. You could think of it as a very, very large office building where there's lots and lots of elevators and tons of people, maybe at rush hour, all moving in different directions.
X and Y sperm are produced in almost equal numbers. Boys are thought to be faster, but the girls live longer. Once created, each sperm ends up in a structure on top of the testicle called the epididymis, a tightly coiled 6-meter-long tube which can hold over 1 billion sperm. Imagine being crammed into a dark, winding, 200-mile pipeline with no idea when or if you'll ever get out. It's here, with no inkling of the horrors to come, our sperm must wait. Their fate now will depend on events unfolding in the outside world. In contrast to the billions of sperm produced continuously in Glenn's body, a woman, like Emily, will produce just 1 egg per month. Reaching it won't be easy.
The battle that sperm have in order to find and fertilize an egg is just immense. Everything is working against sperm. They're not really given a helping hand by the female reproductive tract.
You've got hundreds of millions of cells that are swimming wildly about. You've got a lot of death. You've got a lot of obstacles to overcome.
They've got to make their way through a complex series of environments in a kind of warfare. It is warfare.
So if conception is a war, this is the theatre of operations. From a sperm's point of view, landing in Emily's vagina is like D-Day. Their first objective, whilst under non-stop attack from the female immune system, is to reach a tiny opening high above them at the back of the vagina. From here, they can enter the cervix. The terrain in the cervix is completely different. This is a dark, treacherous maze of uncharted tunnels. The sperm will need to find a way through to the uterus. One wrong turn, and it's a slow, lonely death. In the uterus, Glenn's sperm will be looking for a doorway just a few sperm head wide in a vast, sterile area, where once again, Emily's elite defense force will be waiting to take them out. Then it's on to meet the egg. Timing is everything. Get there a moment too early or too late, and you're doomed.
They're not swimming, they're being forced there by muscular contractions and by peristaltic contractions. From the point of view of the man, it's a very pleasurable experience. But let's think about it from the point of view of the sperm.
250 million genetic couriers are about to invade Emily's body. Within minutes, most of them will be dead. But what chance does an average sperm have of succeeding? To find out, we need to look more closely at the state of our seed, a ritual men like Dr. Alan Pacey have performed on themselves since the invention of the microscope.
I was in my mid-20s and I was a researcher before I plucked up the courage to produce a sample of my own semen and have a look down the microscope. And I remember the first time looking down the microscope, I was just blown away. I almost fell off my chair. I remember having to stand up and walk around the lab and go back and look down the microscope again. And has that really come from me? It was just an incredible sight.
The incredible sight of the sperm cell was officially discovered in 1677 by a Dutchman called Antoine van Leeuwenhoek. The godfather of microbiology, Leeuwenhoek built some of the earliest microscopes, offering him the first, if slightly unclear, image of what he called animalcules, which he theorized contained the nucleus of a human and had a tail equipped with joints, tendons, and muscles. Later, other early microbiologists believed they could see tiny, fully formed people stuffed into each sperm head. Modern scientists, of course, have a much clearer view, but they might wish they didn't, because thanks to the quantity over quality nature of sperm production, a long, hard look at an average ejaculate today gives us the first clues as to why men need so many sperm.
Of the many millions of sperm that are ejaculated, we've got a huge range of different types. If we were to look at them down the microscope, you would see some sperm that were really just hardly moving at all, or just twitching, or some sperm that would appear dead and may well indeed be dead. If you looked at their shape, you would see sperm with large heads, you would see sperm with small heads, you may see sperm with two heads. In an average fertile man, that only 18, 19, 20% maximum of his sperm will have a nice size and shape. The rest, the other 80%, really aren't going to get anywhere at all.
To succeed in the race, sperm must be as fresh and numerous as possible. Any old ones won't make it past the starting blocks, and as they decay, they will release substances that can actually harm younger sperm. Now, ready or not, Glenn's sperm begin their quest for conception in the vagina. Their objective, to find the entrance to the cervix high above them at the vagina's farthest reaches. From the perspective of a sperm, the vagina is like a vast mountain range. It's an enormous and awe-inspiring place. "5 miles deep and 2 miles wide, flanked with vast vaginal walls up to 1 mile high. But it's not just the epic terrain in the vagina, or even their own physical failings that now pose a mortal threat to sperm.
Everything in the vagina is working against sperm's survival. There's only a matter of minutes between sperm's arrival and potential death.
Sperm face attack from every angle. The use of intimate lubricants and even saliva here can render a sperm lifeless in minutes. Worst of all, thanks to the female immune system, the vagina is coated with deadly acid.
The acids are there to kill any invading force. And I think that's a really important point to recognise, because as far as the female is concerned, sperm are an invading force. They're foreign cells. They could be there to cause damage. They could be there to spread infections. They are foreign cells to her. And as far as her immune system is concerned, they need to be destroyed.
Within 30 minutes of entering a vagina, over 99% of sperm will be dead or dying. For our sperm people, it would be a scene of devastation. A few million survivors press on into the dark side of the vagina. Desperate to somehow escape death by reaching the cervix high above them. But the entrance is out of reach. Now, to avoid total annihilation, Emily's body needs to come to the rescue. Emily is approaching ovulation, a process that causes estrogen to surge through her body, softening the hard mucus that usually seals her cervix for the rest of the month from anything nasty. This cervical mucus will drip into the vagina, offering Glenn's fittest sperm a lifeline into the next stage of the race. Back in our sperm people-sized world, what would this lifeline compare to? Well, what if your life depended on climbing a ladder? A ladder stretching over a mile into the sky. It's a long, gravity-defying climb that only a tiny fraction of sperm will be able to manage. For the 60,000 or so that do, it's out of the frying pan and into the fire. Now, they must endure stage 2 of their quest, the cervix. The objective here, to push 4 centimeters to the other side and reach the wide open space of the uterus. Sounds simple, until we take a closer look at the terrain. The cervix is quite simply sperm hell. It's lined with tens of thousands of tiny branching tunnels, most roads to nowhere, and some just a single sperm head wide, where the vast majority, if not all, of Glenn's sperm will get crushed, trapped, and ultimately face a slow death.
Nature does have a selection process in the cervix. It is selecting sperm that are well made. It would be a bit like me, dressed as a sperm, trying to climb a staircase that's a kilometre high. I'm defying gravity, I'm going against the flow, and when I get to the top I find that I've gone down the wrong staircase and I should have gone down another one.
Our sperm must fight their way, crushed amongst thousands of others, up through a twisted, nightmarish urban environment. Only 1% of sperm that make it into the cervix have any chance of making it out alive. Each egg is made even more precious because one will appear for just a few days per month. Many female animals make the most of ovulation by experiencing estrus, where their physical appearance, scent and behavior will change to advertise their fertility. Jeffrey Miller believes women do the same thing.
It used to be thought that humans uniquely lost estrus, that human females don't go into estrus when they ovulate, that somehow we have this pair bond that trumps estrus. But in fact, the new research is showing human females do go through estrus. It serves exactly the same functions that it does for other mammals. All the same hormones, all the same psychology is still right there under the surface of human culture.
So could women effectively go on heat every month? Could their reproductive systems be unconsciously controlling their actions and men's responses? So, with a little help from the unconscious power of ovulation, the great sperm race continues. 250 million of Glenn's battling sperm entered the vagina. Just 3,000 have made it through the dark, twisted hell of the cervix, which now opens out into an environment that is altogether different. As sperm expert Dr. Alan Pacey knows, if you or I were a sperm, entering the uterus would be quite a sight.
From a sperm's point of view, the uterus represents a vast plain across which they have to navigate and find at the other end actually quite a tiny opening that will lead them through to the fallopian tubes.
Scaled up to sperm people size, the uterus becomes a large area of open countryside, 2 miles long and around half a mile wide. For our sperm, finding the entrance to the fallopian tubes, just a few sperm head wide, is like looking for a needle in a haystack. Once again, it's ovulation to the rescue.
Ovulation occurs on one side 1 month, the other side another month. So on the times that the egg is going to be ovulated from the ovary on the left, the uterus seems to preferentially move material to the left-hand side. So the sperm are probably carried to a large degree by these muscular contractions and moved through the uterus relatively quickly.
But on this journey, nothing is ever that easy. Glenn's sperm are about to discover they are not alone. They are running straight into an ambush.
The primary function of the uterus is, of course, to receive the developing embryo should conception occur and to gestate the fetus throughout pregnancy. It's not really designed for sperm, it's designed for something else. It will almost certainly begin to contain leukocytes, and the immune response will be mounted to try and mop up sperm and to try and kill the sperm before they get to the fallopian tubes.
Leukocytes are the assassins of the female body, blood cells commanded into action by the immune system, massing into the uterus in their thousands with murderous intent.
In comparison to sperm, leukocytes are quite large, they're big cells, they often hunt in packs, they will detect a sperm, and many leukocytes will descend upon the sperm and encapsulate it and dismantle it slowly.
For the female body, of course, leukocytes are wonderful and essential things, fighting disease and harmful foreign materials. But let's try and imagine them from the perspective of a trespassing sperm. Once again, Glenn's sperm face utter decimation, as thousands are killed by Emily's immune system. Just a few dozen lucky ones reach the entrance to the fallopian tubes, only to find there is a strict door policy.
Sperm have to display the correct swimming characteristics in order to get through that uterotubal junction. And any sperm expressing a very random form of motion is probably excluded. There's also potentially a molecular recognition system there, so only sperm that are expressing the right molecules actually are allowed through. Sperm have faced death and destruction in the uterine cavity. The leukocytes have been trying to kill them along the way, and only a lucky few, in comparison to the many millions that are ejaculated initially, actually make it into the fallopian tubes, where finally they get to sperm heaven.
Welcome to one of Emily's fallopian tubes. 10 centimeters of what can only be described as paradise for sperm.
The environment of the fallopian tube is just very accommodating for sperm. It's what sperm have been aiming for, and it's set up to try and maintain sperm health, and they can have a rest.
It's got nutrients for them, it's got the right pH, it has the right ion concentration. And some of these sperm will actually bind to the fallopian tube cells. Their membranes will become very closely associated so that the fallopian tube cells can pass nutrients and sugar and protect those sperm.
Scientists believe, with no immune system trying to kill them, sperm can blissfully hang around in the fallopian tubes for hours, even days. But ultimately, it's hard to know for sure. At the farthest reaches of the reproductive tract, the fallopian tubes are very difficult to study. So difficult, in fact, some scientists are willing to go to extraordinary lengths.
When I was done having children, I chose to have my tubes tied, and I told my doctor that I wanted to do an experiment where I had intercourse before I had the surgery, and then she was to cut out that section of my fallopian tubes where the sperm are stored so that I could look at them under the electron microscope and count how many sperm were there. So it was pretty humorous, actually, because I'm coming out of anesthesia, and I was like, did you get it? Did you get it? Because no one had ever done this before. There were about 20 sperm in my tubes that we counted.
Thanks to such dedication, we now have a clearer sense of what happens during the final stage of the voyage to the egg. The sperm's objective: to wait for the egg to appear ahead of them, find it, swim through its outer layer, and be the first to reach its inner core and seal victory. But how will they know when the egg has been released from its follicle?
We're just beginning to understand this, but there's receptors that communicate between the egg and the sperm smell the egg. They're able to sense where that egg is. And you can even see this some in the Petri dish when you're doing in vitro fertilization. If you put an egg in there, boy, those sperm just right away, they orient themselves towards that egg. They're going right towards it. They're not wandering aimlessly around the dish hoping to encounter it. It's not left up to chance. They know what they want to go find.
It's believed sperm wait in the fallopian tubes until they pick up an irresistible scent signal, which intensifies as the egg draws near. One study has shown the scent attracting the sperm smells just like lily-of-the-valley perfume.
The egg basically lays out a red carpet and asks the sperm, this way, this is where you want to go, this is the end of your journey. So instead of swimming backwards into the uterus, they head straight up that fallopian tube, right to the egg, and that's how that final step of the sperm race is won.
She has no idea, but Emily could be pregnant. Beating incredible odds, Glenn's sperm have fought their way through her body and have reached one of her fallopian tubes, where, hopefully, an egg will be waiting. Just single figures have made it this far. Scaled up to people size, what happens next? Imagine an Olympic freestyle swimming final, where the winner gains immortality and the rest are killed. Scent signals released during ovulation will make the sperm hyperactive, giving them the ability to actually fertilize the egg, shedding layers of proteins in a process called capacitation.
Up until now, they've been swimming in quite straight lines, but now their swimming becomes much more erratic. And that tail beat will give them power and propulsion in order to get through the outer coat of the egg.
All of a sudden, they are 100% on target. They want to find that egg, they want to penetrate that egg, and it is a race for the finish. Once they capacitate, sperm die within just a few hours. So it's a no going back.
On the sperm people scale, the egg drifts just a mile or so ahead. But as our reproductive scientists can testify, the egg's 24-hour lifespan will present the sperm with one final, fatal hurdle.
What needs to be kept in mind for this whole great sperm race is timing. Timing, timing, timing. Because the egg has a limited lifetime.
What if the egg arrives a little earlier? Well, you want some sperm to be able to capacitate relatively early. What if that egg comes maybe a few hours from now or another day? Well, you don't want all of the sperm to be capacitated right at the beginning because then they're going to die.
Having arrived hours before the egg, these sperm reach the end of the line, falling into the abyss beyond the fallopian tubes. Behind them, just 2 heroic sperm remain, all that survives of a 250 million. These two, a Y chromosome-bearing male sperm and an X chromosome female, left Glenn's testicles 14 hours ago. They've endured an incredible journey, and against overwhelming odds, they've got their timing just right. At the farthest reaches of Emily's reproductive system, the egg is waiting. If you or I were a sperm, the egg would soar into the sky as high as a 10-story building.
During the great sperm race, there's been this great attrition of sperm from the point of ejaculation through to the fallopian tube. Actually, at the site of fertilization, when the egg is being fertilized, there may only be 1 sperm, there may be 2 or 3, but only very few sperm are actually fighting for that final prize. Eventually, 1 sperm will hit the outer coat of the egg, and this is it. This is the moment that they've been waiting for.
To secure victory, all this sperm has to do now is find a way inside.
The sperm is carrying this genetic payload for delivery, but that genetic payload has to be able to get into the egg. And the way that it gets into the egg is the sperm literally blows its top.
Above the head of the sperm, there's kind of a bag of juices, a bag of enzymes that are really important at this stage of the process. By touching an egg, that bag bursts, and those enzymes will facilitate the sperm in finally penetrating through the outer coat of the egg.
The great sperm race has been won. The victorious male sperm is instantly devoured as Glenn's genetic information merges with Emily's waiting DNA.
So you get this elegant dance of male chromosomes and female chromosomes coming together, which will officially announce the fact that that egg is fertilized and that new life has been created and development of a new individual has started.
Just 14 hours ago, hundreds of millions of sperm embarked on the most incredible adventure in the natural world. An adventure that claimed all their lives. So what made that winning sperm special? Why did it succeed over billions of others?
When you think about the odds that any single one of us are here right now, compared to the hundreds and millions of other sperm that in that ejaculate were left behind, there could have been smarter offspring, handsomer, more athletic, better in every way, ones that just didn't make it because they either weren't in the right place at the right time, or, they just didn't find their way through the cervix or the uterotubal junction, or maybe they capacitated a little too early before the egg got there, or maybe they were, a little too late to capacitate. So there's just a lot of luck involved with it, as well as to which sperm actually is able to fertilize.
Yet one unremarkable sperm, against odds of trillions to 1, did not die in vain. It has given its life to start an utterly unique new one.